Yeah, g'day, Mark here, and welcome back to my channel. Now, this is going to be another episode of the never-ending grinder wheel hubs thing. Now I have a bunch of wheel hubs which have their first and second operations completed, but there are three which have got some issues that need to be addressed. Right, so this one, can't remember what I did, but I managed to wipe out the balance weight groove. This all looks pretty ugly, but really it just needs a bit of light cleanup and it'll be fine. I'll just use this as an unbalanced wheel or do the balancing with the ballantron. This one, I tried milling out all this with a mill toolpath and the part moved. So I'm going to have to remove all of this and just leave this as an unbalanced flange, and also it won't have this sort of dust cap which is supposed to keep the dust away from the bearings. Probably going to end up with some weird wheel on it that I don't use much. And this one looks really nice until you see it's got cracks in it. One here, one there. Not sure how that happened because this is still over 2 millimeters thick. I'm guessing that it was possibly a build-up of swarf and then the pressure of the tool being pushed out against it snapped it, but it seems like the lathe would stall before that happens, so not really sure. So what I'll have to do here is just turn away all this section and probably a little bit of the flange as well, just to get rid of those cracks. I guess this one's also going to end up without any ability for balancing. Oh hey, look at this. I was just taking a look at the set of nuts that I made, and I see that those same cracks are in a couple of the nuts too. What I'm guessing is that that is not a crack caused during the machining, but that there was a defect in the original metal billet that we didn't turn out. Now, to make sure that all of the turning I do is concentric to this mounting taper, I'm going to need an arbor. So I'll make it out of a slug of steel like this. And probably the most accurate way for me to hold it would be to use a collet. Since my largest collet is 25 millimeter diameter, so first up I just need to take this down to 25 millimeters, because then I can also transfer it across to my indexer on my mill for doing the final couple of processes. It's good enough. Right, now I'm going to need to put a 1/2 inch by 16 TPI left-hand thread on the end. So let's first just take the stock down a bit. While I'm at it, I'll also give it an undercut at the back for the threads. Perfect. So now we can cut the taper. Okay, just cut it to 26 millimeters just to get a feel for how it's cutting. It's looking pretty good. Final dimension here is like 17 millimeters or 18 or something. Better go and measure it. Oh, wait a minute. I only went to minus 30. I'm starting at minus 15 and going 30, so it needs to go to minus 45 plus a bit. So I've blued up one of my existing holders. Now this taper is not yet finished. I've still got another 1.5 millimeters to go. Just want to get a feel for the taper angle and stuff. Okay, that seems to be reasonably even on the back, but the front taper looks like it hasn't even got up onto there yet, has it? I need to cut it a bit deeper. Now, one of the things I'm a bit curious about here is how repeatable is this collet. You can see that it's got sort of a groove machined into the end of it, so it's definitely not new. It's done some work. Let me just throw a clock on it. Since I haven't yet finished cutting the taper, I can still take it out, put it back in, play around with it, see how repeatable it is, and then decide whether I have to keep this in the same position for the entire machining or whether the repeatability is good enough. Wow. That's kind of surprising. This was machined in this collet, in this setup. Why has that got any movement at all? This spindle's very stiff, so you can only get a slight bump on it by pushing on it. But as you can see, I've got 3/100ths of a millimeter of total run out as machined. That's not good. Let's try rotating it, putting it back in and seeing what happens. Okay, that run out increased to 5/10ths or so. It's really not good. Well, I guess this says that I have to set everything up and do all the machining in one go and keep the pressure on, because I think turning off the machine overnight and turning it back on this morning, that change in pressure must have explained that initial run out. But before I get to finishing off this taper, one of the main issues I have in machining is that I don't tighten my work holding tight enough and then have my part slip or move. I don't want that to happen here. I've only got a plain taper to mount the part and provide friction, but I do need to do some light cleanup passes on quite a large diameter, so there's going to be quite a bit of torque on that taper. So I'm going to have to make sure I crank this retaining nut down nice and firmly to prevent the part spinning. So for that to happen, it'd be good to have a wrenching flat here that I can hold my arbor nice and firmly while I crank down the nut. So I think I'll do that next. Now to mill wrenching flats into here, I'm going to need some way of holding this on the milling machine. And because the wheel hubs have a couple of milled features or drilled features, which I need to do after the turning, I may as well set up my indexing system now and mount that straight in my indexer. The one job where I really need to think about putting up some sort of a crane, because this is a pretty heavy beast. Every time I use this, which is not often enough, I do struggle with the whole programming of this. I find kind of unintuitive, but I think I've got it. So line 1 is going to go to 180 degrees, and then I need to go to input to jump to line 2, which takes me back to 0. Right, that's all I need for this one. But I machined that for a 22mm spanner. Oh yeah, that looks fine. Actually, I might just go a little bit further that way because I think this is going to get covered up by the wheel hub. Well, I've got it set up, why don't I take it over 2 more millimeters? Right, let's give a light pass over this taper. I've slightly adjusted the angle because it felt like it was touching at the front but not so much at the back, so just steepened that angle just slightly. Okay, what the hell happened there? Oh! are supposed to be turning to a small diameter of 18.75 and not a negative number. So unfortunately I've already blasted through to 17.5, which is only slightly under what it should be, but that looks like it might be right on the limit there. I mean, I may be able to rescue it by cutting the taper just a little bit deeper. Okay, rescue attempt. Okay, how's that looking? Oh, good. That is now sitting on the taper. I'll glue it up and see what it looks like. Good contact at the back, but looks like I'm a bit lacking on contact at the front now. Okay, well, it looks like I've got contact at both ends. Now, because I cut this under size, I'm now going to need to move this edge back as well so that I've got something to clamp against. Let's get started. Don't need a washer on there because I had to move that back a bit. Cool, let's see how this is going to work, huh? But all the tool parts for this have been handwritten. I like to do these with a set of subroutines because then I can just turn them on and off if I have to repeat one. That's a pretty decent fit. What about with one of my homemade nuts? That's looking good. Oh, so the thread's a good fit, but then it binds up at this back chamfer. I wonder if the chamfering tool damaged the thread or something. Let's try another one. Yeah, also good fit, also binds up at the end, so gonna have to do something with those nuts, I guess. How's it gonna come off? This is such an awkward spanner, you having to use some sort of a bar on it. Oh, there it goes. So I can use the normal extraction tool that I made for taking these off the grinder. Oh, cool. That worked well. Just make sure I got the hub diameter correct. Yep, that's fine. Cool. It's one down, 13 to go. Well, it looks like this insert's starting to get a bit worn. You could definitely hear it and see it in the amount of heat coming off, so let's turn that. Hey, did all of you in Europe get out to have a look at the solar eclipse this week? Well, so here we are at the near total eclipse. It's only just started now, so it's got a ways to go. Here in Vienna, we only got to about half eclipse before the sun went down over the Viennese forest. Now things were going swimmingly well, and I was about halfway through the 14 hubs that I need to make. Now unfortunately, when disaster struck, I wasn't filming. A part spun, the nut came off, and then the part jammed itself back on the taper. Not good. That came loose, had to e-stop it. It looks like that plunge cut to clearance this part dug in. The thing spun. I've just realized that the direction of rotation here is opposite of the direction of rotation of the grinder, and therefore that left hand thread is wrong. It should have been right hand. Duh. It spun, it undid the nut, but now it's tight. So did it friction weld itself onto that shaft? And what does that shaft look like? I guess before I take it all apart, let me put a clock on it and see how round it's running. Okay, that's not running round at all. Well, I guess the best thing is to take this out, separate them, and see what problems I've got. Oh, that was tight. So it definitely didn't spin in the collet. Did these weld together or do they separate? Oh, ouch. Okay, well it didn't friction weld itself together, but it sure as hell galled up. It trashed the arbor in that form. I'd say that that wheel hub is probably also scrap. I don't think I can recover that. Bugger. That was one of the nicer ones too. Well, that's a bit frustrating. Every time I think this week I'm going to finish all my wheel hubs, the wheel hubs are like, hey, hold my beer, watch this. I mean, it's obviously a big brain fart on my part to put that left-hand thread on here. That should have been a right-hand thread from the start. However, that's 1/2 inch. So I think what I'll do is turn it down to 10mm right hand. I've got this nice nut that I could use to clamp, but I think this arbor is long enough that I can chuck it up a bit shorter in the collet, turn a new taper onto it, shortening it a bit, and putting a new thread on the end. As in, I guess I can remake this arbor, but using the same piece of steel. Thanks a lot for sticking with me on this. I'll see you next time.